Today we're going to go a little bit further with our dimensional analysis. We are going to look at problems that have exponents in the units, and then we'll also look at problems that have 2 units per one number. So to start, we're going to convert 25.0 cubic centimeters to cubic millimeters. So we're just going to start with our game plan. So the only number given is 25.0 cubic centimeters. And if we read the word problem, we see that we're trying to convert that into cubic millimeters. And the next step is to figure out our conversion factor. So our conversion factor is we're going to know 1 centimeter is equivalent to 10 millimeters. Except now we're looking at cubic centimeters and cubic millimeters. We can keep the same relationship. We're just going to cube it. All right, so once we have our game plan and our conversion factors figured out, we can actually start the dimensional analysis. So I'm going to draw my boxes. And the only number given is going to go in that first box. So we have 25.0 cubic centimeters. And so if cubic centimeters are in the top box, that means cubic centimeters have to go in the bottom box. And if I use my conversion factor, we have 1 cubic centimeter, and then that's equivalent to 10 cubic millimeters. And so if we look at our units, the cubic centimeters cancel, and the cubic millimeter is what's left. So now this should look pretty familiar up until this point. Okay. The only difference is we have this cube symbol. So I'm going to add some notes before we calculate. Okay. Your starting number has already been cubed, so you are not going to cube this in your calculator. All right, and then when we use our conversion factor, this has not been cubed yet, so yes, you need to cube this in your calculator. So now we'll solve it just how we always have. So we're going to multiply the top row. So we're going to take 25. And remember, we're not going to cube this one, so just 25. And then we're going to multiply it by 10 cubed. You do have to include the cubed in the conversion factor. So go ahead and practice. So get out your calculator right now, and you can pause this video. And I want you to practice typing in 25.0 times 10 cubed. And then once you calculate it, you should be getting 25,000 millimeters cubed. And then last step is going to be significant figures. 25.0 has 3 significant figures. When we go from metric to metric, we don't count these for significant figures. So since we have 3 in this number, we need 3 in our answer. So we're going to convert our answer to scientific notation. So I'm going to write 2.50 times 10 to the 4th power, and our unit is still millimeters cubed. So now we're going to look at dimensional analysis problems that deal with 2 units, such as miles per hour, or maybe meters per minute. We're going to do a couple of these just so you can start to get the hang of them. So for this first one, if your pace on a treadmill is 65 meters per minute, how many seconds will it take for you to walk a distance of 8,450 feet? Okay, so first, we just need to look at all the information given to us. So we know we're going 65 meters per minute. We know our distance is going to be 8,450 feet. And then we're trying to solve for how many seconds it's going to take us to go that distance if our pace is 65 meters per minute. So step one is just to organize your information. So I'd recommend reading the word problem, you can underline, and then rewriting all of your information below so we have it all in one spot. And then before we do the dimensional analysis, we're going to make that game plan. And so this time, you're given two different numbers. Up until this point, you've always been given one number, so that's the one you start with. But now, since you have two different numbers, you have to be able to identify which one is your starting number. And so here is how you're going to identify it. 65 has 2 units. It has meters per minute. 8,450 just has 1 unit, feet. Okay. You will always start with the number that has 1 unit. Okay. So that means we're going to start with feet. And eventually we have to get to seconds. So this conversion factor is going to help us do that. It's going to allow us to get from distance to time. Okay. So if we look at this, it's 65 meters per minute. Our distance is in meters. So we're going to have to convert from feet to meters. And then from meters, we can get to time, so we can get to minutes. And then finally, we can convert to seconds. So now that we know our plan, we can do our dimensional analysis. So I'm going to draw my boxes. And we just established we're going to start with feet. So we're going to start with 8,450 feet. And that's going to go on the top box. Okay. Just a 1 in the bottom box. And now we have to get from feet to meters. If you don't know how many feet are in a meter, you can just Google like how many feet are in a meter. So I'm going to look it up. And then if the unit feet is on top, the unit feet has to be in the bottom. So when I look up this conversion, I see there's 3.28 feet for every 1 meter. So feet cancel. We're now in meters. And then we can get from meters to minutes by using our speed. We're going 65 meters for every 1 minute. So if meter is up here, the unit meter has to go in the bottom box. So we're going 65 meters. And we're going meters per minute. Per means the number 1. So 1 minute will go in the top box. So meters cancel. We're left in minutes. And now we'll convert to seconds. For every 1 minute, there are 60 seconds. So again, minutes cancel. The only unit that doesn't cancel is seconds, and that's what we want our answer in. So now we know we're ready to calculate. So we're going to multiply the top row and get an answer. So again, feel free to pause my video and actually calculate. So if I multiply the top row, I get 507,000. Then we're going to multiply the bottom row. So 3.28 times 65. I get 213.2. And now we'll just divide the top row divided by the bottom row. All right, so when I divide them out, I get 2,378.05. And then our final step is going to be to count significant figures and round that answer. So 8,450 has 3 significant figures. 3.28 has 3 significant figures. 65 meters per minute only has 2 significant figures. And then 60 seconds is equivalent to 1 minute as a definition, so we don't count this for sig figs. So 65 is going to limit our answer. So when we look at rounding, the 3 is our second sig fig. So we're going to look to that 7 to see if we round it up or down. And so since that 7 is greater than 5, we're going to round this up to 2,400 seconds. All All right, let's say a car is traveling 60 miles per hour. How many inches per second is it moving? So I'm going to start by just writing my information down. So I know we're going 60 miles per hour, and I'm going to write it as miles divided by hours. And we're trying to figure out how many inches per second that's equivalent to. So this time, you're given one number, okay, but that number has 2 units. It has a distance and a time. And we're also trying to convert it into a distance and a time. Okay. So we're basically going to do 2 conversions all in one set of boxes. So we're going to convert miles to inches and hours to seconds. Okay. So when we create our plan, we're going to go miles to inches. And do we know how many inches are in a mile? Probably not, but do we know how many feet are in a mile? So we can go from miles to feet to inches. And then to convert time, we're going to go from hours to seconds. And if we don't know how many seconds are in an hour, we can go to minutes in between. So we can convert from hours to minutes to seconds. Okay, so once we have a plan, now you can start your dimensional analysis. So I'm going to draw our boxes. Okay. We're back to only be given one number in the word problem. So that number is what we start with. So we have 60. And do you see how it's miles divided by hours up here? I'm going to keep it miles divided by hours in my dimensional analysis boxes. So I'm going to put 60 miles in the top box. And then this divided by an hour, I'm going to put it as 1 hour in the bottom box. Okay. So again, we're miles divided by hours. I'm still miles divided by hours. Okay. So now I'm going to convert between miles to feet to inches. And I'm going to do that first. We're just going to ignore this 1 hour for the moment. We'll come back to it. Okay. So first we're getting from miles to feet. Okay. If miles in the top box, then miles has to go in the bottom box. So for every 1 mile, there's 5,280 feet. Okay. So miles cancel, and we're in feet. And now we're going to get from feet to inches. For every 1 foot, there's 12 inches. So feet cancel. We're in inches, which is what we want to be in. So now we're going to go back, and we're going to convert our time. We're going to go from hours to minutes to seconds. Okay. So we know there's 60 minutes in an hour. This time, do you see how hour is in the bottom box? That means the unit hour needs to go in the top box so we can cancel that unit. And we know for every 1 hour, there are 60 minutes. So this time hours cancel. And now we're in minutes. So we know there's 60 seconds for every minute. And now, since minutes on the bottom, minute has to go up top, again, so we can cancel that unit. So for every 1 minute, there's 60 seconds. Okay, so if you see what units are left over, we have inches in the numerator, seconds in the denominator, and that's what we're looking for. So this is a really good indicator that we set up our math correct. So now we're going to solve for this problem. So we're going to multiply the top row and get an answer. And then we're going to multiply the bottom row and get an answer. And then we're going to divide them. So go ahead and pause the video and actually calculate both the top row and the bottom row. Okay, so when I multiply the top row, I get 3.8016 times 10 to the 6th power. When I multiply the bottom row, I get 3,600. And then now to solve for your final answer, you just divide the top by the bottom. So I get 1,056. And then the final step is to count sig figs. Notice you're given 60 with a decimal point. So this is 2 sig figs. 5280 is 3, and the rest of these are definitions, so we don't count them. So since there's 2 in our starting number, our answer can only have 2 sig figs. Okay. So the 0 is that second sig fig, and we look into the 5. The 5 is going to cause us to round up to 1,100 inches per second. Okay, one last practice problem. Bailey, the French bulldog, walks at a pace of 0.80 feet per second. We're going to convert this to miles per hour. So this problem is pretty much identical to the previous problem. Okay. So I'm going to start by writing down the number given in the word problem. So you're given 0.80. And feet per second is the same thing as feet divided by seconds. And we're trying to convert this to miles per hour. Okay, so miles divided by hours. Again, 2 units to 2 units. So we're going to do 2 conversions all in one set of boxes. So we're going to go from feet to miles. And then seconds to hours. If we don't know how many seconds are in an hour, we can go to minutes in between and then to hours. Okay. And then once you have your game plan set up, you're ready to do the dimensional analysis. For this one, since it's just like the previous one, I would like you to try it on your own first. So go ahead and pause the video and get as far as you possibly can without my help. And then once you get as far as you can get, go ahead and turn the video back on. And then you can either check and see if you got it correct, or if you got it incorrect, you can follow along as I go. All right, so I'm going to start by drawing my set of boxes. 0.80 is the only number given, so it goes in the top box. And then my unit is a foot divided by a second. So I'm going to make sure I have feet divided by seconds in my box. So I have feet divided by seconds. And then my first conversion is feet to miles. So we know that there's 5,280 feet for every 1 mile. So now I'm in miles. And since I'm in the unit that I want to be in for distance, I know it's time to figure out my time conversions. Okay, so I'm going to go from seconds to minutes. And again, this time, since seconds is in the bottom box, seconds has to go up top. So there's 60 seconds for every 1 minute. So seconds cancel. And then now we're going to get from minutes to hours. We know there's 60 minutes for every 1 hour. Okay. So minutes cancel. So again, our only units that don't cancel are miles in the top box, hours on the bottom box. And you should notice that this is matching. It's miles divided by hours. And in our dimensional analysis, we're still miles divided by hours. So that's your clue that you're ready to calculate. So if we multiply the top row, we get 0.8 times 60 times 60. So I'm getting 2,880. If we multiply the bottom row, we're getting 5,280. And then now when we divide 2880 by 5280, I'm getting 0.545455. And then last step is just to round to number of sig figs. 0.80 has 2 sig figs, 5280 has 3, and then again our times don't count since they're definitions. So this is our limiting sig fig, which is 2. That means our answer can only have 2 sig figs. That 5 causes us to round, so we're going to write 0.55 inches per second.